Hello everyone. Today we're going to look at some application problems. So we're going to be looking at 3 different applications. The first one is heart rate, or your targeted heart rate during a workout. The next one is BMI, your body mass index. And the third one is ramp calculations. So heart rate. The following equation is used for finding your target heart rate for cardio exercise. Before I get to the equation though, we need to find your maximum heart rate, and that's just 220 minus your age. So your target heart rate is your maximum heart rate minus your resting heart rate times the intensity plus the resting heart rate. So the resting heart rate is your heart rate when you get out of bed in the morning or after you've been resting. An intensity is a percentage, and a common target heart rate has an intensity between 60% and 80%. So when I multiply it by intensity, it's going to be a percentage which you change to a decimal. So if I had 70%, that would be 0.7. If I had 65%, that would be 0.65. So we're going from percentages to decimals. Percent means per cent meaning 100. So 60% is 60 per 100, or 60 divided by 100. So you're going to take the percentage, divide it by 100, and dividing by 100 translates to moving your decimal over 2 places. Okay, so 20% would be 0.20, 45% would be 0.45, and so on. So when it says times intensity, it's the decimal version of your intensity. So a 50-year-old man wants to find his target heart rate for a 70% intensity workout. If his resting heart rate is 50 beats per minute, find his target heart rate. So the first thing we're going to do is find the maximum heart rate, which is 22 minus his age. So 22 minus 50, and that's 170 beats per minute. And then we plug that into the target heart rate equation. So it is the maximum heart rate minus the resting heart rate, so that 50 is not his age, it's his resting heart rate, times the intensity as a decimal, plus the resting heart rate. Make sure when you're plugging into your calculator that you do order of operations, right? I need to do the parentheses first, then multiply by 0.7, and then add 50. And I should be getting 134 beats per minute. A 35-year-old woman has a resting heart rate of 65 beats per minute. Find her target heart rate for a workout with an 80% intensity. So again, the first thing we have to do is find the maximum heart rate, 22 minus her age, which is 185. And the target heart rate. So again, it's her maximum heart rate minus her resting heart rate times the intensity as a decimal plus, again, the resting heart rate. So you use the resting heart rate twice. So again, following order of operations, we should be getting 161 beats per minute. A 40-year-old man has a resting heart rate of 45 beats per minute. Find his target heart rate for a workout of 50% intensity. So his maximum heart rate, 220 minus 40, is 180. His target heart rate, maximum minus resting, times intensity, plus resting. And we should be getting 112.5 beats per minute. And the last one, a 60-year-old woman has a resting heart rate of 60 beats per minute. Find her target heart rate for a workout with a 60% intensity. So it's a lot of 60s. Maximum heart rate is 220 minus her age, which is 160. Target heart rate, maximum minus resting times intensity plus resting. So again, it's a lot of 60s, and hopefully you know which 60 is coming from where. And we should be getting 120 at the end of that. Okay. So you won't have to memorize any of these equations, okay, because they're only on the homework. They're not going to be on the actual test. The next one is body mass index. So the BMI is a measure of health and wellness. What it is it's a comparison between your height and weight, but it doesn't account for the different types of weight, i.e. fat versus muscle. So when you find your BMI, you have to use it with some caution. Sometimes it's higher than what it would indicate because muscle weighs more than fat. So it's not something to be used strictly as is. But here are the basic results from it. If your BMI is less than 18.5, you're considered underweight. A normal weight is between 18.5 and 25. Overweight is between 25 and 30. Obese is between 30 and 40, and extremely obese is anything above 40. So when you're getting your answers, make sure that your answers are somewhere in this range. If you're getting a BMI of 100, there's no way that's possible. If you're getting a BMI of 2, that's not a human being. Okay, so make sure your answers are reasonable here. So how we calculate it depends on what units we're using. So you have to pay attention. Are we in the metric system or are we in what we use in the US? Do we have kilograms and meters or do we have pounds and feet or inches? So if we're in metric, then the BMI is the weight in kilograms divided by the height in meters squared. Because of conversion numbers in English, we have this 703 involved. So it's the weight in pounds times 703 divided by the height in inches squared. So find the following people's BMI. Height of 63 inches and a weight of 125 pounds. So we have inches and pounds, so that's the American system. So we're going to take the weight, 125, multiply it by that 703, divided by 63 squared. And we get 22.14. B, a height of 182 centimeters and weight of 68 kilograms. So this is the metric system. Don't worry, you're not going to be given a mix. You're not going to be given inches and kilograms or pounds and centimeters. So it's either strictly the American system or strictly the metric system. So this equation is a little easier. It's just 68 divided by 1.82 squared. So this is centimeters, and this has to be meters. So remember, to go from centimeters to meters, we divide by 100. So 182 centimeters is 1.82 meters. And if we do that out, we get 20.53. How about a height of 68 inches and a weight of 200 pounds? So we got inches and pounds. So again, we're going to have this 703 coming into play. So 200 times 703 divided by 68 squared, 30.41. And then a height of 170 centimeters and a weight of 75 kilograms. Centimeters, kilograms, that's the metric system. So I'm going to take my 75, divide by, again, 170 centimeters is 1.7 meters. So divided by 1.7 squared. And we get 25.95. Okay. We can also use this table. So in the homework, you're going to have questions where you need to do the formula and where you need to use the table. I have a lot of people who don't do both. So I'm going to go over how to use the table. So down the rows, we have the height, and we have it in inches and in centimeters. And then across the top in the columns, we have the weight. So if I'm looking at someone who is 61 inches, I'm going to be following this guy across. So there's my 61 inches. And then if they are, say, 150 pounds, the BMI is 28. If they are 200 pounds, the BMI is 37. So these aren't exact, right? There are some rounding issues here. So it's better to use the actual formula, but the table's faster. Okay, so make sure you're reading the question, whether it's using the formula or using the table. if I had someone who is, say, 180 centimeters tall, I would have to use this 180.3. So again, I do have to do some rounding. And then if they were, say, 64 inches, 64 kilograms, I'd have to go somewhere between the two. Okay, so I'd go 64 is closer to 63.6, so I would say it's 19. Okay, so it's not exact, but it is faster. There's no actual math involved except for which number is it closer to. Okay, so make sure you know how to use both. On the other hand, typically after a certain age, you no longer grow vertically, so your height doesn't really change. And because of that, we can think of BMI and weight as varying directly with each other. As your weight goes up, your BMI goes up. As your weight goes down, your BMI goes down. And therefore, we can use proportions to solve certain problems. So we got to go back to how do we solve proportions. So your BMI is 27 and you want to make it 25. If you weigh 180 pounds, how many pounds must you lose? So again, BMI and weight vary directly. So I can look at BMI over weight, or I can go the other way and do weight over BMI. Right? The order doesn't matter as long as on either side of the equation it's the same order. So I'm going to look at which am I solving for. I'm solving for pounds, so I'm going to use the version with the weight on top. So my first equation is I weigh 180 pounds and the BMI is 27. So that's my first side of my proportion. And then how many pounds must you lose? So that's not really X. We'll get into what X is in a minute, but X is the weight. And the BMI is 25. So the weight is on top, the BMI is on the bottom. And again, I'm doing this because I want to solve for what's on top. It's a lot easier. So to get X by itself, I'm going to multiply both sides by 25. So what is 25 times 180 divided by 27? So that's 166.6 repeating, really 2/3. But I'm going to round here to 0.67. So that's not the answer to the question. I don't want to lose 166.67 pounds. Right? This is my new weight, or what I want my weight to be. It's not a very good E. So to find out how much I want to lose, I'm going to take my 180 and subtract my 166.67. So you must lose 13.33 pounds. Okay, so make sure that you answer the question. Sometimes it's what must your new weight be? Sometimes it's how much must you lose or how much must you gain. So make sure you're answering the question. I have to lose 13.33 pounds. Let's try another one. You originally weighed 200 pounds and then lost 50. If your BMI was 31, find your new BMI after the weight loss. Okay, so again, I'm going to use the proportion, but now I'm looking for BMI, so I'm going to put the BMI on top. So for my first one, I weighed 200 pounds. My BMI, or your BMI, was 31. So again, BMI on top, weight on the bottom. My BMI that I'm looking for is on top. The new weight is 200 minus the 50 that you lost. So this is going to be X over 150. And again, if I want to get X by itself, I'm going to take my 31 over 200 and multiply by my 150. So the new BMI is 23.25. Okay, let's look at the last one, which is ramp calculations. So the ADA, the Americans with Disabilities Act, requires for commercial use of ramps is a ratio of 1 to 12. So 1 inch of height for every 12 inches, or that's supposed to be an or 1 foot of length. This is equivalent to an incline of 5 degrees. So we have a ratio, which means we're going to be using proportions. And depending on what units we're given, we're either going to use the ratio of 1 to 12, which is inches to inches, or 1 inch to 1 foot. So if we need a ramp to reach a height of 32 inches, how long must it be? So we're going to use the 1 foot to 1 inch rule, and I'm going to flip it because what we're looking for is the length of it. So I'm going to put the length on top. Okay, so 1 foot per 1 inch is length to height. So x is my length and the 32 inches is my height. If I solve it for x, hopefully we can all see it's going to be 32, and my units is feet, so it's going to be 32 feet. If I wanted to find it in inches, then I would use the 12 inches to 1 inch, and I would solve that one, and that would give me the length in inches. Okay, so it's really important that you use units here. If we have a ramp that covers 200 inches in length, how high can it rise? So now my length is in inches, so I'm going to use the 12 because that's in the inches. So my 1 to 12, I know my length, so I'm going to put the length on the bottom, and I'm looking for height, so I'm going to put the height on top. So now I'm reversing it back to the original 1 to 12. So 1 to 12 equals x over 200. To find x, multiply both sides by 200. So 200 divided by 12 is 16 2/3 inches. Okay. So just make sure that you're using the correct ratio, whether it's 1 to 12 because it's inches and inches, or it's 1 to 1 because it's inches and feet. Are the following ramps too steep to pass the ADA requirements? So remember, the requirement is the ratio 1 to 12 if we're talking about inches. So if I put that as a decimal, I get 0.083 repeating. So if the ratio that I get out from the information given is less than this, then we're safe. If the ratio is higher, then the ramp is too steep. So what if we have a length of 400 inches and a rise of 25 inches? So that would be the ratio of 25 to 400. Remember, it's height to length. And that gives 0.0625. So that passes the ADA requirements. It's not too steep. What about a length of 300 inches and a rise of 3 feet? So now I have inches and feet, but the rise is the feet, so I have to change this into inches. Whoops. So to go from feet to inches, I need to multiply by 12. So I get 36 inches, and that's the number I need to use for my ratio. I get 0.12, so it does not pass. And the last one, a length of 24 feet and a rise of 30 inches. So I can tell right away it's not going to pass, because if it's a rise of 30 inches, then it needs a length of 30 feet if we're looking at the 1 inch to 1 foot ratio. And 24 feet is not at least 30 feet. So I know that it's not going to pass. Okay. So make sure you read through this section. Again, it's kind of a long section. There are 3 very different things in it, but it's not on the test, so you don't have to worry about having any of it memorized. But I do want you to be able to use it, so I want you to be able to do the homework from it. Okay, so let me know if you have any questions. Thanks.